All right, guys. So your unit exam is going to have 17. That's 17. Okay. Multiple choice questions. And 7 written problems. Okay. And those written problems, they will, some of them have like an A and a B and a C and a D. I think they only go as far as D. And there's only a couple of them. Okay. And there are 48 marks in the written. All right. So the whole test is out of 65. Pardon me? No, I don't do numerical response. I feel like your method is worth something. Numerical response makes all your work worth 1. Yeah. Alberta Learning might think that numerical response are okay on diploma exams and that everything can be tested by multiple choice. I like to think of them as wrong. Okay? Because I don't buy that. Okay. So, first thing we went over in this unit. First thing we went over was we reviewed scalar and vector quantities. Okay, so yes, it is definitely important for you to know which things are scalar and which things are vector. Right? And not because I would have like a multiple choice problem or not multiple choice question that said which of the following are vector quantities. I probably will, but that's only 1 mark. Okay, here's where knowing which things are scalar and which things are vector is most important. If I was to give you a position versus time graph and ask you to calculate something, the way we calculate vector quantities off of a graph is sometimes different than how we calculate them off, or how we calculate scalar quantities off of that same graph. Okay, so it's important to know which things are scalar and which things are vector. Or similarly, because this one gets people all the time, let's say I give you an acceleration problem, and I say something like, this object has an initial velocity of 10 meters per second. It's accelerating at -2 meters per second squared for 3 seconds. What is its final velocity? And you write a number with no direction on it. That's speed. Okay? Or, conversely, you forget to make acceleration negative because I said that it was and it's a vector quantity. Okay? Something like that. Okay? If I say instead of it's negative, it slows down. Okay? Understanding which things are vector and which things are scalar are important for things like that. They're going to cost you more than 1 mark if you forget that that's a scalar quantity or that's a vector quantity. All right? So, the quantities we went over were these. Our scalar quantities are time, distance, speed, energy and work. We haven't dealt with energy and work in this unit, but we will in the next unit. Okay? Our vector quantities were displacement, velocity, and acceleration. All right, so definitely know which things are which. That same day, we reviewed the use of these 2 formulas. V equals d over t and v equals d over t. Okay? One of them being speed equals distance over time, and one of them being velocity equals displacement over time. And the other thing we have to remember about that is that this can also be written this way. Final position minus initial position over time. Okay, displacement is our change in position. Okay, now, am I going to have a 4-mark v equals d over t problem in the written part of your exam? No, that's beneath you. Okay, I might have a multiple choice question where you have to do that worth 1 mark, but no. Do we have to use v equals d over t in anything else though? We use it in graphing, okay? We use it in projectile motion. So it's going to come up, right? And you got to be able to use it and manipulate it. But again, that's not going to be a challenge for you guys. You're fine with that. All right, next thing, graphing. Okay, so we got position versus time, and we got velocity versus time graphs. Those are the two we went over. We did a lab on each. Am I going to ask you to do the same things on the unit exam I asked you to do in the lab? Yes. Not just almost definitely, just definitely. Okay, I'm going to ask you to do all of those same things. So, in case you've forgotten, okay, the things I asked you to do from the position versus time graph would be to calculate total distance, total displacement, average velocity, average speed. Okay. Now, some things we have to remember about graphing are, at least for the position versus time graph, or be able to figure out, is how do I get those things? Right? If I have a graph that is irregular, then I would just use these formulas right here. Okay? I could find initial position and final position on the graph. That is, after all, what it shows me. Okay? And I could calculate all of those things. I can read time directly off the graph. If the graph is a single linear function, and I'm given the equation for the line, could I do a lot less work and get to velocity? What would it be? Yeah, it would be the slope of the line. Okay, so things like that. Okay, could just know that those are things that we went over. Those are things that were important in the lab. Those are definitely things I'm going to ask you to do. Okay. So using y equals mx plus b is definitely going to be part of this on either one or both of those graphs. They are both on there. Okay? There's one position versus time graph question in the written. There is one velocity versus time graph question in the written. Okay? And there's a couple in the multiple choice as well. All right, so if I had these two graphs, let's say. All right, so this one here being the position versus time graph on the right-hand side. All right. If I've got all of this information, which I would have, okay, what's my velocity? 1.5 meters per second. Okay. If I had a more irregularly shaped graph, so if I had something like this, okay, where it started right here and ended, let's say on the x-axis, pretend I didn't draw that a little bit. Right? Could I calculate my total displacement? Yeah, it'd be final position, 0 minus my initial position. I would have a negative displacement in that case. Okay, things like that. Right? If I wanted to calculate the total distance off of this graph, right, then I would have to figure out how far did I go in this section. So that would be final position minus initial position. What happened here? Nothing, yeah. We're going to pretend it's horizontal. I know it doesn't look perfectly horizontal. Okay, it's horizontal, so that object wasn't moving. Is that something I might ask of you on the exam? Yeah, probably more multiple choice. Okay, there's a graph. What's happening in the graph? Okay, that's a multiple choice kind of question. And then here, what's the object doing?
Accelerating negatively.
No, it's not. What does acceleration look like on this graph? Curved lines. This object is just moving backwards negatively at a constant velocity, yeah, a constant rate. Yeah.
So it's slowing down?
Nope, not slowing down. If it was slowing down, then it would look like this. It would be curved, right? Okay? Any acceleration, be it positive or negative, is a curve on a position time graph because how far we go changes each second. This is showing that how far I go is constant each second, right? But the curve shows that it isn't. All right, so things like that, that's analyzing a graph. That's definitely going to be on there, okay? But so are the calculations that we went over. If I had a velocity versus time graph like the one on the left here, okay, then I would have to, I'd be given the equation for the line. What would the slope represent on this one? Yeah, the slope would represent acceleration because it would be meters per second minus meters per second, or VF minus VI, divided by time, y minus b over x. All right, so things like that definitely could be on there. On your lab, I asked you to calculate the total displacement, okay, which was calculating the area under the line, or we actually found that there was a shortcut. Did we have a formula that calculated the area under the line? That calculates the area under the line. Okay, this part here calculates the triangle. This is base times height. That calculates this. And could I get all the numbers I need for that from here? Yeah, A would be the slope, B would be VI, X would be T. Okay? Yeah, A would be M. The acceleration would be M, yeah. Okay, all right. Questions on that? So definitely expect graphing. There's significant marks on graphing, okay? Because those are the questions that have the A, the B, and the C, and D, okay, on them. So, you know, that's the ones that there's some marks there. All right, acceleration. There's going to be some very simple problem solving in the multiple choice, but there's also going to be problem solving in the written. Like there's a dedicated acceleration problem in the written, right? Like which you would have had on your worksheet, okay, something like that. But is it also part of projectile motion? Yeah, we got to be able to use our acceleration formulas in our projectile motion problems, so definitely know how to use your acceleration formulas. Okay, and there could be the odd, like, multiple choice problem about the nature of acceleration, like what it is, what it looks like, what it means, okay? All right, vector addition. There's vector addition on there. 2 questions in the written. And there's a couple of multiple choice questions about method. Not asking you to actually calculate anything vector-wise unless it's like super simple, like forward and backward. Okay, there's some of that in the multiple choice. But the stuff where you'd have to draw the diagram, the triangles, the tail, the head, all of that kind of stuff, that's in the written. Okay, so there's one, like I've told you about 4 times would be on the exam. Okay, so one that's, you know, horizontal or vertical and one that's angled. So there's one like that. And there's a boat question. Okay.
Is there a boat question number 9 on the assignment?
I am not going to give you that much information. I do not recall, Senator. Okay, problem solving. So yeah, and like we said, boat questions. Okay, the tail, the head is in there. Remember, we have boat questions that are rowing across. Both the ones on your assignment were rowing across questions, and going across questions, which mean you row slightly into the current and the current pushes you back to straight across. Okay, either one could be game for your unit exam. Okay. And then projectile motion. And we've already said there's one of each kind in the written. And there's like 1 or 2 multiple choice questions, but they don't involve any calculating, they just involve the principles of projectile motion.
What was the class average of the test/semester?
I don't put a lot of stock in class averages. I used to, but I don't anymore. I mean, I have 2 physics 20 classes this semester, one period 1, one period 2. It is entirely possible they could have class averages up to 10% or more different. And they had everything the same. So I don't put a lot of stock in it. So much depends on, you know, the makeup of the class. And sometimes it's like, because it's after lunch, people are sleepy, like it is. Yeah. A lot of years of teaching have told me over the year course average is probably more meaningful. But I don't know what that was either. Okay. Okay, on multiple choice. Okay, we got to talk about how you do multiple choice here because this annoys me. Whoop. Okay, so you guys have all used the zip grade forms before, right? Pretty much everybody uses those now. Okay, first off, bring a pencil to your exam. So you can do the multiple choice in pencil. It's not like the old Scantron where it had to be in pencil to be scanned. It's just so that if you make a mistake, you can fix it. Because this is what I have people do. Okay, they read through the question like, oh, it's totally C. And they fill it in. Really good. Super dark. And then they realize, oh, it wasn't C. So they do this. And they fill in A. And they go super dark. And oh, no. And they literally do this. Do you know what my phone says when it scans that? Wrong. And you know what my phone is? Right. Okay? Erase it. Okay? When you fill in multiple choice the first time around with your pencil, just do that. Okay? Just a little bit. And then when you check it over, you can fill it in darker when you're a little more sure. Okay? Because that happens all the time. It's you know, it scans it and it's just like there's so much, it's not erased properly or they literally did this. Okay? Like it's, yeah. All right? Just pick one answer. There's only one correct answer. Okay? If I mess up, and this has happened, if I mess up and there are two correct answers, I will code them both because I can do that. Technology's awesome. I can say that both C and D are right. Okay? So if both C and D are right, I will put in that both C and D are right, but only pick one of them. Okay? Yeah. All right. Other thing here, guys, just in having a quick look, I've marked, you know, some of the vector assignments here. Do you know what thing is getting people most?
Oh,
No. Oh, I did that.
Sig digs. Big. Okay? That is getting people big time. So remember the rules for significant digits are as follows. Whatever number you use for a calculation, whatever is the least accurate, that's the number your answer can have. So if, for example, I was doing a vector addition question where I had how many significant digits can my answer have? Two. Both magnitude and direction can have 2. Okay? Both magnitude and direction can have 2. Must have, not just can have, must have 2. Because I'm going to use this number to calculate something that will contribute to my final answer. Thus, its accuracy, which is only 2 significant digits, affects the accuracy of everything I calculate with it. Everybody follow me there? Okay, now, there's one situation on that assignment, and it's this one. No, it's 4.6, wasn't it? It's 4.6. This is an incredibly rare situation. What am I going to do with these two numbers? I'm just going to add them. They're collinear. That means that the angle isn't used to calculate the magnitude. In a vector addition question like this one, it is. But in this one, it's not, which is why when this is all said and done, these things are added separately. So, that is basically the only situation where your vector and your magnitude could have different amounts of significant digits because they actually don't affect each other. Because they were collinear, I didn't actually use the angle to calculate the other number. Okay? This would have been like adding 4.6 kilometers north to 3.2 kilometers north. The north didn't really have any effect on anything. Okay? Neither did the 35 degrees north of west. It's an incredibly rare situation. Okay? Most of the time, and by most I mean like 99% of the time, this rule applies. Okay? We rarely do a one-step mathematical problem in this course. Okay? All right, so yeah, remember your significant digits and your vectors, because, well, they're important. Okay, and so a lot of your answers will move. All right, so your unit exam, as I said, 17 multiple choice questions. In the multiple choice, expect to be asked things that are like vocabulary or conceptual, lots of stuff about scalars and vectors, things like that. A couple of graphs, 3 graphs. But they're either an incredibly simple calculation on the graph or their interpretation of the graph. Okay. Yeah, there's like there are, out of 17 multiple choice questions, 3 of them require calculations. 2 of the 3 could probably be done in your head. Okay, so the mathematical stuff is in the problem solving. Okay, is in the written part. All right, and as we said already, in the written part, you've got 2 projectile motion problems, 1 acceleration problem, 2 graphing problems, a vector addition, and a boat question. Okay, gives you a pretty good idea what to expect this Monday, I would think. All right. Anything you'd like me to go over? Any questions that you have that I can answer for you?
Would you be allowed to write on the test?
Yes. I don't know how you would write it without. So yeah, it's you definitely are going to write on the test. Write all over it. Okay. If you like to highlight things that are important in questions, go right ahead. You do you. You've got to do whatever is going to help you with the test. Write all over it.
On our workbook, it has an exam review thing, but it doesn't have the answers with it.
Right. I think I posted the answers in the key, or in the thing I posted on Google Classroom. Let's double check. Pretty sure I did, but let's double check. If I didn't, we'll fix it. Yeah, the key is right there. Okay, so it's down on March 6th, so that was Monday. Okay, so this is the last page. The one on the right is the last page in your work booklet, and then this is the key. So you can check your answers as you go there. Okay. And I think there's a few that actually do have the answers with them. Now, some of the stuff in this file here, in this review file, is beyond what I'm going to ask on the test. Okay, so for example, when you get to these extra kinematics review questions, the challenge problems are way beyond anything I'm going to ask on the test. They're in case you're getting cocky and you need to be humbled a little bit. Okay, so then you can do those, and if you don't feel humble after those, then you deserve to be cocky. Okay, yeah.
Let's try one.
Oh, you go ahead if you want to, but I'm not going to do it here. Okay, all right, other questions? What else can I answer for you? Or review in more detail?
Can we actually do like a specific example of a problem?
Okay, yeah.
Like the boat questions, not like the first one where it's like going across, but the one where you said the current like pushes you.
So going across.
Yeah, going across.
Okay, a going across boat question. I guess I don't have a going across one. All right, let's look at a going across one. Okay, so. That answer doesn't make any sense. Sorry guys, this one I gotta think, I gotta actually do the math before I can write it up. I still did that wrong. Okay, hang on. Okay, sorry, that took a long time. That didn't show us making the question up right. Okay, so we got a boat going across a 60-meter wide river by rowing at a 20-degree angle into the current at 3.6 meters per second. The current is flowing downstream at 1.23 meters per second. How long to cross the river? All right, what do I need to do first?
How wide the river is.
Yeah, I've got to draw, well, not so much with how wide the river is. That's going to go here. I am going to draw that on here, but it's just 60 meters across. I want to draw my rowing speed and my current speed, okay? Because that's going to make a vector diagram for me. Which direction is my resultant going to point? Straight across. That's the key to a going across versus a rowing across question. Okay, in a going across question, you're rowing, which would look like this. I'm rowing into the current at a 20-degree angle. Okay, the current is going to go onto the end of this. And be 1.23 meters per second, which means now my resultant is actually this side. It's not the hypotenuse, but it is the resultant velocity of the boat. It just happens to go straight across because the question says a boat is going across. Right? That means it's going straight across. Okay, so I'm trying to figure out a time here. What do I need to find first?
Result.
I need to find my resultant velocity, yeah. Okay. Is there a quick way to do that? I could do Pythagorean theorem, but I think there's an even quicker way.
3.6 cos 20.
Yeah, 3.6 times the cos of 20. I have the hypotenuse of that triangle and I have the angle. I want the adjacent side. The adjacent side is actually my resultant. Okay? Because when I row at an angle into the current, it actually slows me down. Okay, is everyone kind of following me on that? Right, if I row a little bit into it, it's a little bit harder work, so I don't go quite as fast. So my resultant is actually going to be smaller than the speed I'm rowing at. Okay? So 3.6 times the cos of 20. So 3.38 is going to be that side. Okay, how does that help me? Right, now I can use this. I couldn't use the 3.6 with the 60 because the 3.6 doesn't point across. The 60 points across. So I need a velocity vector that also points across. This is another thing I saw people mess up on the boat questions on the vector assignment. They used their resultant to calculate the time to get across when their resultants pointed this way and across pointed that way. Can I use vectors together like that if they don't point the same direction? All right, so I got 3.38, I got 60. Time to cross the river is going to be 60 over 3.38, d over v. 17.75. We have two significant figures, 18 seconds to get across the river. Okay, what else?
Can we do another projectile motion curve question?
So, fired at an angle question? Okay, let's do that one. Okay, so we've got a projectile that is launched at a 30-degree angle above the horizontal at 50 meters per second. I want the horizontal distance and the maximum height. Okay, so on this one, okay, we've got to break it up into our vertical and horizontal components. Okay, right away, let's calculate V horizontal and VI vertical. Okay, so this will be the cos of 30 degrees times 50. Okay, so 43.3 meters per second. And then on this side, VI vertical will be the sine of 30 times 50, which is going to be positive 25 meters per second. Okay, A is going to be negative 9.81 meters per second squared. And since we're not told otherwise, VF will be negative 25 meters per second. And of course, our overall displacement over the whole flight would be 0. All right. If I want to calculate the horizontal distance, then I need the time. Okay, time I would get over here, same as we always have, VF minus VI over A, so negative 25 minus 25 over negative 9.81. Okay, so 5.10 seconds. Okay, so now we can go V times T, and we'll get our horizontal distance. All right, so it's going to travel 2.2 times 10 to the 2 meters horizontally. And then to calculate maximum height, okay, you got your two ways to do it. Okay, so I would say D equals VF squared minus VI squared over 2A, okay, would get it for you. So that would be 0 minus 25 squared, okay, divided by negative 19.62. So 32 meters would be our maximum height for that one. All right, tomorrow I will hand back the vector assignments and we will go through them at the beginning of class. I'll answer any questions you have on that. And then we will move on to Unit 2. We'll start talking about Newton's first law. Okay.